All right, so we got a quiz tomorrow. So I'm not going to give you like specific numbers on these, but I'll show you the style of problem they are, okay? I don't want to give too much away. I would hate to do that. And you would too, I'm sure. Because you probably would rather study this yourself, wouldn't you? All right, so number one, I ask for the sum of the measures of a particular polygon. The sum of the measures of, and I'll give you a specific polygon. Give me a good polygon. What's your favorite polygon? Pentagon? Okay. We'll go pentagon. All right, so how would you find the sum of the measures of a pentagon? What do all five angles add up to be is what they're asking you. Do you remember a little formula for it?
180.
Yeah, 180 is involved.
N minus 2.
You got it. N minus 2, what?
Times 180.
Times 180, okay? So that's your formula right there. What does the N represent? How many sides you have. So how many sides does a pentagon have? 5. So you go what? 5 minus 2 times 180. That's 3. And what is that? 540? Is that right?
Yeah, that's what I said.
Will I show what? No. I'll just say it. You don't have to see it. You just got to know how many sides you have. Okay? If you know how many sides you have, you should be able to do this pretty easy. Would you agree? What's another one? Hexagon, right? Octagon, septagon, nonagon, decagon. Doesn't matter. I mean, it could be a quadrilateral, but that'd be too easy though, because that would just be 360 every time, right? Even if it's a trapezoid, even if it's a parallelogram, none of those things really come into play. It's just how many sides you have. It doesn't matter. It doesn't have to be a regular pentagon. What does it mean to be a regular pentagon? Well, it's 5 sides because it's a pentagon. What's the difference between just an ordinary everyday pentagon and a regular pentagon?
All the sides are the same.
And all the angles are equal to each other as well. Okay, so if it says regular, then all the angles and all the sides would be equal. So that brings us to number 2. It's going to say find the measure of each angle. Each angle of a regular, and then whatever. Give me something else, not a pentagon. What's one of your favorite polygons? Do you have a favorite? Hexagon? Okay. Hexagon. All right, so how do we do that? How do we find the measure of each angle of a regular hexagon?
Minus 2 times 180.
Yep, you still do the n minus 2 times 180 because that'll give you all the angles, right? And then you divide it by what? Right, the number of sides or angles, which is going to be the same thing, right? So you just divide it by that. So let's do it. So n minus 2, let's do that in our head. What's that? It's a hexagon. So 6 minus 2 is 4 times 180 over what? Over 6, right? Because the n, right? This is n minus 2. It's 6 minus 2, right? By how many angles you have. Agreed? Can you do this in your head? Or without a calculator? Look, 6 goes into 18 how many times? 3, right? So that's 30 times 4 is 120. So a hexagon, each angle of a hexagon is 120 degrees. Of a regular hexagon. I should have said that. Okay? Because if it's not regular, then you don't know what all the angles, right? They could be different angles, couldn't they? They could all be different angles. All right? So the only way to figure it out is if it's a regular hexagon. Make sense? We got time. We started this pretty early. Let's do this. What if...
Would the Feinstein please come to the office and see Mr. Osborne, Ryan Giannini, Jazara Boyd, Jaden Alexandri, Gio Maldonado, Ben Andrew, Tyler Tickle, Judah Johnson, Jasmine Herbert, Emma Eachis, Josiah Davis, Deanna Velasquez, Dennis Doyle, and Logan Hill.
My
Thank you.
goodness. It's a lot of people. They got enough room in there? All right. Let me show you another way to do this. I don't know if I've shown you this before. We talked about the exterior angle. Do you remember we talked about the sum of the exterior angles of any polygon? What is it? The sum of the exterior angles of any sided polygon. It's the same number. It doesn't matter how many sides. You could have 4 sides, you could have 10 sides, you could have 1,000,000 sides. The exterior angles are all going to add up to the same exact number. It's not 180. 360. It adds up to 360. So, watch this. Everybody watching? What if you didn't want to go through all this mess, right, to figure out what that interior angle was? Okay, you could very easily find the exterior angle. So let's say this is part of a hexagon, all right? This is just a little part, okay? That's only 2 sides, but there's 3, 4, 5, 6, okay? You with me on that? It's a regular hexagon, all right? So what would the exterior angle of a hexagon be? Again, how many degrees? How many degrees are all the exterior angles? What do they add up to be? 360. How many exterior angles would there be? Excuse me. On a hexagon. If there's 6 interior angles, how many exterior are there going to be? 6. Okay. So how many of these angles are there? Right? If I did this and did exterior, 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 there'd be 6 of them. And they all add up to what? 360. Now again, it has to be a regular hexagon for this to work. But then what would I do? 360 divided by what? 6. That's easy. What's that? 60. So the exterior angle is 60 degrees. But that's not what they ask for. They ask for the interior angle. If you know the exterior is 60, it's very easy to find the interior. You guys aren't trying. I can see it. I can just see it. You're just waiting for me to get over this until get to the next one. I can tell in your eyes. Come on, let's think about this, okay? Let's use a little brain power. So now we know the exterior angle is 60 degrees. How do I find the interior angle? That's right, because it forms a straight line, right? So they're supplementary. So what's 180 minus 60? It's 120. So this interior is 120 degrees. It's not a whole lot easier, but I think it's a little bit easier to find the interior angle if you know the exterior angle. And it's kind of easy to find the exterior angle. It's always 360 divided by how many angles you have. Make sense? All right, so if it's a hexagon and the exterior angle is 60, the interior angle is its supplement, which is just 180 minus 60, which is 120. So you could have done it this way, right, and you get 120, or you could have done it this way to get 120. Yes? A regular, any polygon. It could be 1,000,000 sides, and all the angles will add up to 360. How is that possible? Because as you get more and more sides, what's happening to your exterior angle? It gets smaller and smaller and smaller and smaller, okay? That means it's going to take a whole lot of angles to get that 360. Make sense? Okay? Right. So if you had, let's go octagon. Let's find each interior angle of an octagon. Let's do it this way, though. Okay, so what do we do? 360 divided by 8. I don't know what that is off the top of my head. Let's see. Anybody know? 360 divided by 8. It's 45. So that's the exterior angle. What's the interior angle? How do I find the interior? Yeah, it's 180 minus 45, which is 135. So you got your exterior and you got your interior. It's pretty easy, isn't it? Once you understand about the exterior angles. Yeah. Okay. Just thought I'd throw that out there. We didn't talk about that earlier, but I probably should have at some point. But now I did. All right. Enough of that. Does it make sense? I think it's kind of easier way to do it, don't you? Than the n minus 2 times 180 divided by n. It's really not that much easier. I think it's that much. Just a little smidge easier. All right. What do you know about a rhombus? This is number 3. What do you know about a rhombus? What's true about it? Okay, it is a four-sided figure. It's a quadrilateral, but specifically it's a what? Did we do rhombus? We did, didn't we? Yeah. Okay, it is a parallelogram. That's true. But specific about being a rhombus. What's true about a rhombus is not true about just any other ordinary parallelogram. Denise, what'd you say? 4 equal sides. That's correct. Does this one work? No, that's not what I wanted. Oops. It could be a square. Let's do... Not what I wanted. That's okay. I'll make it look like I want it to look. Ooh, that's terrible. What am I doing? Why isn't this... Yeah, we'll just do it like this. And then I'm just eyeballing it to see if that side and that side are the same. That's pretty close, isn't it? Yeah, that's pretty close. So this is a rhombus. What do I know about a rhombus? All 4 sides are equal. So if I tell you one side, if I told you that's 5, then what's this side right here? 5. But I'm not going to get that easy. All right, what I'm going to do, don't write these numbers down because I don't know if this works out, but I'm going to give you this in terms of x, and I'm going to give you this in terms of x. Does that make sense? So like, I don't know, 2x plus 3. Again, don't write this down because I don't know if this comes out real nice and pretty, but if I had something, I don't know, like that, then what would you do with these two? How would I find the length of all sides of the rhombus? Yeah, just set them equal to each other, solve for x, chuck it back in, right, and then you get it. Okay, that's number 3. Super easy. Super easy. I'll keep that there. Okay? What if you had a trapezoid, but not just any old trapezoid? What's a special kind of trapezoid that we've talked about? Isosceles trapezoid. Good. And I'm trying to draw this as close as I can to an isosceles trapezoid. That's pretty close. This would be number 4. Okay, and it is an isosceles trapezoid. So there's a couple things we know about an isosceles trapezoid. And what do we know? Well, if it's trapezoid, how many parallel sides does it have? It's just got 2 sides, or 1 pair, correct? Just 1 pair of parallel sides, exactly 1 pair. All right, because if it had 2 pairs of parallel sides, then it wouldn't be a trapezoid. What would it be? If both pairs of opposite sides were parallel. It hasn't been that long. It'd be a parallelogram, right? If both pairs, you gotta say it louder because I'm getting old. My ears are getting worse. I need to go in and get my ears checked or something because I do ask what a lot more than I used to. So maybe I'm not hearing as well as I used to. That's what happens. I'm 60. I'm an old man now. So, so you know these 2 sides right here are parallel to each other. What do I know? If it's an isosceles trapezoid, what do I know about this side and this side right here? Then they're equal to each other in length, okay? So they are equal to each other in length. All right? Everybody with me on that? So they give you some information. Again, they give it to you in terms of x. They'll say this is like 3x plus 1. They'll say this is 5x minus 7. I don't know, whatever. You know, whatever letters and numbers they use. But you do know that these two are equal to each other. So if they give you this in terms of x, they give you this in terms of x, just like on this one, you would set them equal to each other, solve for x, and then boom, you're done. Question? Correct. On a trapezoid, you can only have one pair parallel to each other. And the pair that are not equal to each other are always going to be the parallel sides. You got it? So the non-parallel sides would be the ones that are equal to each other. That's isosceles. All right. Well, you're going to use the ones that are equal to each other to solve for whatever letter they ask you to solve for. Okay? Once you get that letter, you can plug it in and you can find the lengths of all four of those sides. Right? So the key is just solving for x or whatever your variable is. All right, number 5. I'll draw a picture for you. So you got one that looks like this. You got one that looks like this. Like this. And like this. And let's just extend this one a little bit. There we go. All right, and they tell you that's a right angle. And they'll give you this angle right there. Let's put in something on our own, okay? I'm not going to use the one from the quiz, but what do you think that degree looks like, that angle looks like? 100? Yeah, I'd probably say more like 120. So let's put 120, okay? And they want you to find the other angles. And they also tell you that this is a right angle. So what do they want you to find? This one and this one. So that should be pretty easy. We just kind of talked about this one right here. What's this, really? Super easy. 60, right. So that's 60 degrees right there because that's 180 degrees, right? Take 120 away from 180 and you get the 60. What else? This angle up here. How would you find that? You could do it several ways. There's one real easy way. Watch. If these are perpendicular, if they're right angles, right? They're perpendicular to each other. What must be true about this line segment and this line segment? The line segment itself. Line segments can't be supplementary. Angles can be supplementary. Parallel to each other. That's right. Because these are, I used to say same side interior angles. What do we call them? Consecutive interior angles. Right? They're supplementary, so that must mean this is parallel. So check this out. Without doing any math at all, you should be able to find this angle right here. Or you could do some math, okay? You could do some math and find it as well. But I think it's easier not doing any math, just looking at it and say, oh yeah, that's, boom. What is it? Parallel lines, right? And this is a transversal. Why 120? What do we call it? They're not corresponding. No, nothing's being bisected. No, they're not consecutive interior angles. This one and this one would be consecutive interior angles. What is this 120 and this angle right here? They're not corresponding. They're alternate. Keep going. Very good. They're alternate interior angles. Now, did you have to know that to get the answer for this? No, you didn't have to know it, but I'm just trying to get you to remember those things because I think it's important. So look, this angle right here, 120, is the same as this angle right there. All right, they're alternate interior angles. Or another way, if you didn't see that, I'm just trying to show you the easiest way to do it. Isn't that nice of me? All right, so here's another way you could do it. Again, parallel lines, transversal. These right here are consecutive interior angles. So what do we know about consecutive interior angles? They are, no, they're not equal. Look, that's acute and that's obtuse. There's no way they're equal. They're supplementary. That's right. So if this is 60, then this is 180 minus 60, which is what? 120, just like we said it was. Wasn't it easier just recognizing that they're alternate interior angles? Absolutely. Okay. If you wanted to, you could have done this. What do all four of these angles add up to be? 360. So that's 90 and 90, that's 180, right? So you could take 360 minus 180, which is 180, minus 60, which is 120. Now that would be too complicated. I mean, it's not that complicated, but it's just so much easier just looking at it and saying, oh, they're alternate interior angles, so they're equal to each other. Wouldn't you agree? Yeah. All right. All right, we're halfway done. Oh, okay. I see what they're doing. I didn't think they gave you enough information at first, but now I see it. All right, what if you had, it's just some kind of random polygon. It's not a trapezoid, it's not a parallelogram. It's just some random four-sided figure like this and like this. Looks like they might be parallel to each other, but if they don't tell you, can you make the assumption that they're parallel to each other? No. Okay. So what if I gave you this in terms of x? I'm not giving you actual numbers here. I'll let you do the math yourself. You should be able to do it. But what if I gave you this in terms of x? Do you know what that means? What does that mean? I give it to you in terms of x. There's an x in it, okay? It's not really necessarily an equation, but this could be like 3x plus 2, right? This could be like 5x plus 7 or whatever. You with me on that? So I do that with all four of these. So what do they all add up to be? 360, right? So you would take this one plus this one. We'll just do this. We'll call it A, B, C, and D. Is that all right? So what you would do is you would take A plus B plus C plus D equals what? 3, oops, got ahead of myself. 360. All right? And again, this A, B, and C, and D will all be written in terms of x, right? One might be 2x plus 1. The other is 3x minus 2. The other one is 5x minus 7. Whatever. I don't know. Okay? And then you just add them up. Set them equal to 360. Do your algebra. Now you have an equation, right? Because you got it equal to something. So now you do your math. Solve for x. Plug it back in. And you can find whatever angle they ask you to find. Yeah? Yeah. That's easy. You just have to know to add them up and set them equal to 360. The rest you should be good with. All right, let's talk parallelograms. We haven't even done a parallelogram yet, have we? So let's do one. Let's make this. Let's make it the other way. There we go. All right. All right, here's our situation. They give you a bunch of stuff, okay? Let's just talk about this. This is a parallelogram, so you know that the opposite sides are what? Parallel to each other. You also know that the opposite sides are what? Equal to each other. So that would be equal to that one. This one would be equal to this one. Okay? You know something about the opposite angles of a parallelogram. What do you know about the opposite angles of a parallelogram? They're equal to each other. So this angle and this angle up here are equal to each other. This big angle right here, that whole thing, right? And this big angle right here are equal to each other. We good? All right. And they're going to give you some stuff, right? They're going to tell you some things about the sides. And you're just going to do some math and figure it out. They'll give you this, like in terms of x or y. They'll give you this in terms of x or y. So what would you do if they gave you this one and this one? Just set them equal to each other, solve for x, plug it back in, and then you got the length of whatever you need to find. Okay? You with me on that? All right. And then they'll tell you some stuff about the angles. Okay? They might tell you this angle and this angle or one or the other. They probably won't tell you both, because if they tell you this one, you know what's true about this one, right? They're the same, right? What's true about this whole big angle up here and this one down here, this 2-arc angle and this 1-arc angle? They're equal to what? 180, right. They add up to 180. Let's not say they're equal to 180, because what you're really saying, when you say they're equal to 180, you're saying that's 180 and that's 180. All right, but they do what, though? They add up to be 180, all right? I know I'm being kind of picky, but you got to be. All right, what about this one down here, this bottom left one, and this big bottom right one? They're also add up to 180. Or instead of saying add up to 180 all the time, we could just use one word and say they're what? They're supplementary, okay? We go to that. What do you know about these 3 angles? That angle 1, that angle 2, and that angle 3 right there. They do what? They add up to 180, right? They're supplementary as well, okay? So again, I'm on purpose not trying to completely give you the problem, all right? You are an honors class, so I'm giving you enough that you can go and study, all right? You can look at this, look in the book. My guess is, I can't remember, it's been 2 or 3 years since I made up this quiz. My guess is I probably grabbed this from the book somewhere, all right? So look for it. But you should be able to do this pretty easy. So this is number 7 and 8. I asked you a question about the sides, and I asked you a question about the angles, okay? So I ask you one of the sides, and I ask you for one of the angles. What's that? I am recording it, yes. All right, one more. You ready? Another parallelogram. In fact, let's grab this one, paste it, and I'm just going to twist it a little bit. So I am actually giving you a lot of information. Let's do it like this. It doesn't make any difference. I am giving you a lot of information, even though I'm not giving you exact numbers or anything. I mean, if I gave you exact numbers, that'd be like me just taking the quiz for you. And I know you don't want that, right? Wouldn't you feel left out if I just gave you everything? All right. All right, I'll tell you this. Again, I'm not, unless you find one from the book, we can put some numbers in and actually do one. But we did this just the other day. I think Friday we might have, when we went over some questions. I think we went over some questions on Friday. And let's just talk about this for a second. This is a parallelogram. They tell you at the beginning it's parallelogram ABCD or PQRS or whatever letters they use, okay? So that means that these two are parallel. It means these two are parallel. And it means all the other stuff that we talked about before. The opposite angles are equal. The consecutive interior angles are supplementary and all that. But now we have a couple things that we didn't have on the other one. Now we got 2 of these lines that go through the middle. What do we call those things? Do you remember that? Starts with a D, a diagonal. Very good. So we got 2 diagonals. Do you remember what happens with those diagonals? They bisect each other. Good. So that means that this and this are equal to each other, and this one and this one are equal to each other. So you know what they're going to do. They've been doing this all quiz. I've been telling you all quiz. They're going to give you, I don't know, something like this in terms of X, right? Or in terms of A, or in terms of B, or whatever letter we decide to use, okay? And then they give you this one, like in terms of A or B. In fact, they might give you this Yeah, I think that's all I'm going to tell you. I'm trying to just figure out how much I want to let you know. But I think this is good. I will give you a huge hint on this one. This is the one where you use substitution. Okay? So, like, this might have an X and Y in it, and this might have an X and Y in it. Or this might have an A and B, and this might have an A and B. All right? But you remember what you got to do. You got to do that little substitution thing. So I'm not going to do one of those problems for you, but we did them together in class, right? I don't know if I had it recorded or not. I think when we first did the lesson, we might have recorded one of those substitution ones. I don't know. I don't know if it's recorded, but we've gone over them in class, right? We did homeworks. We went over it in class. So just make sure that on 9 and 10, you understand that you're going to probably use some substitution on that. And I just ask about the sides. I don't ask anything about the angles on 9 and 10. All right? So on numbers 9 and 10, I'm just asking you the lengths of sides. So look, I could give you this side right here. I could give you this. I could give you one of these, right? I could give you this. I could give you the whole thing, the whole diagonal. If I gave you that whole diagonal, then this would just be half of it, wouldn't it? That little bit right there, okay? And so on. Yeah, so very similar to the problems that we did, and we just went over it. I just remember going over it not too long ago, right, with the substitution. So that's 9 and 10. Denise? Yes, fill out a pass. Okay? Does that all sound familiar to you? Pretty easy? Xavier, you got all that stuff? Yeah? Even through the snoring, you got it? Yep. Okay. Okay. No other questions? All right, that's it.